Welcome back. We are talking about wastewater treatment, under which we are dealing with sewage quality parameters. In this video, we'll be talking about some of the chemical quality parameters. The first one is the pH, which will determine the acidic or alkaline nature of the wastewater. If it is less than 7, it is acidic, alkaline when pH is greater than 7. And usually strip method, electrometric method are used. And you can see here the number of strips are there, and you take the sample and then you dip this litmus paper. Depending on the color obtained on the litmus paper, we will compare the color with these standard colors and find out what is the pH of that particular sewage sample. Otherwise, we are having electrode method, like we tested pH for raw water. So we use the electrode and then calibrate the instrument for known pH values and then test the pH. Usually the drinking water limits are around 6 to 8.5, but for the sewage, will be the sewage, the pH will be around slightly highly alkaline, okay, up to 9, 5.5 to 9 pH. pH is given by minus log H plus, which is equal to log 1 by H plus. And the total dissolved salts, so number of salts are present in the wastewater, calcium, magnesium, sodium, potassium, chlorides, so sulfates, hydro, bicarbonates, and carbonates. It will give salty taste to the wastewater or raw water. So we are having electrode method or gravimetric method. So nowadays gravimetric methods are not regularly used because of availability of more sophisticated electrodes. So we are having portable meters as well as laboratory used electrode method. And then oil and grease. This is another important parameter which will occur in kitchen operations, workshop garages, industrial operations, where they are using oil and grease and other fatty material in their operations. Oil and grease is nothing but a fatty material found in milk products and oil usages. And what is the problem with this oil is it forms a thick layer on fresh water, not allowing sunlight to pass through. So this hampers the photosynthesis operation. And when the sunlight penetrates only to the lower levels of water, the algal photosynthesis is going to take place. Otherwise, it's not possible. And when the oil is floating on the water, surface water, it will give you objectionable or murky appearance here in the water. And if you are sending this water or wastewater for treatment in the treatment operations, this oil will stick to the surfaces of the equipment and then cause clogging also, and hampers the treatment operation and pumping of wastewater. And also when oil is floating anywhere in the liquid surface, it will encourages the mosquito breeding and fly nuisance. So in inland surface water, if you are throwing this water, say wastewater, it should be less than 10 milligram per liter as oil and grease, or less than 20 milligram per liter when it is disposed into sewers and marine disposal. How you are going to detect this oil and grease? So now what you are doing is this is extracted through hexene or ether. The sample is mixed here with dilute HCl to form fatty acids. First of all, the fatty acids are formed which are removed by evaporation. In this evaporation process, we are mixed with the hexane or ether and heated. So when you are heating the sample, what is going to happen is vapors will go, and then top you are having indirect cooling in the condenser. Because of the cooling, these vapors, whatever are there, they are getting condensed, and then they are getting collected in the solvent bottle kept in the bottom. So because of this particular process, now what are the residue is there? Residue is collected separately. So that residue is nothing but the oil and grease content in the sample. So this is called Soxhlet apparatus. This is oil and grease. And this is the experimental method for detecting the oil and grease in the laboratory. Iron, it occurs mainly in the water in two forms, either the soluble ferrous iron and insoluble ferric iron. Water contained ferrous iron is clear and colorless because iron is completely dissolved. Water containing ferric oxide is not soluble here. The water or wastewater doesn't matter. Iron is always there. From we are talking about sources where exactly this iron is entering from wastewaters, from industrial dumps or wastewater dumps in the leaching. Leaching means nothing but the solid waste dumps are there. From there, iron will enter into the surface water bodies, and leaching from iron ores, iron deposits, corrosion of iron pipes, all these will lead to deposition of iron in the wastewater. So when iron is present, it will give reddish brown color formation, and excessive ferric iron causes deposits in pipes and leads to less water supply pressure or plumbing issues. How you are going to detect? It is detected through color comparison using spectrophotometric method. The permissible limits, if you look at when you discharge into inland waters or on land or marine disposal, it should be less than 3 milligram per liter. Manganese is another impurity in wastewater. It is present in the water in the environment from natural sources, rock or soil weathering, a result of human activities such as mining, industrial discharges, and landfill leaching. It will give a pink color to the water, loss of memory and attention. Infants may suffer from learning and behavior problems. The limits of this manganese is less than 2 milligram per liter in inland waters, on land disposal, and marine disposal. Chlorides will come from domestic wastewater, industrial wastewater, aquacultural ponds, saltwater intrusion, agriculture runoff. In the domestic activities, we'll use common salt, sodium chloride. And sodium chloride, when you throw it, the liquid or water having salt content, it thrown into the sinks, it will enter into the sewer lines in the form of sodium chloride mixed in the water. So that's how the salts are getting entered from the domestic sources in the houses. Similarly, industrial wastewater, where a number of chemicals are used in the operation. Aquacultural plants, they mainly prefer the brine water. Brine water is nothing but the smaller concentration of salt, less than that of seawater salt concentration. Because whatever the aquaculture is going to grow, they should be adaptable to the seawater environment. So that's why the water should have high salt content or high chloride content. Salt water intrusion coming here, and then that may enter into the groundwater. And agricultural runoffs are also there. So you're detecting through silver nitrate and converts into silver chloride. And limits in drinking water is only 250 milligram per liter. There are the detection limits for chlorides in wastewater are not prescribed yet. Phosphates, agricultural runoff, industrial wastewater, refuse dump runoff. Algal bloom is going to give, algal bloom means the growth of surface of the water filled with the grown up plants. It reduces passage of sunlight through water body and causes anaerobic conditions below the top layer of the water. So when the treated wastewater or raw water entering into surface water, this should be less than 5 milligram per liter. More than 5 milligram per liter means that algal bloom is going to occur on surface of the water bodies. And sulfates. Sulfates, again, it causes corrosion of pipes and distribution system. And it can come from sewage treatment plants, industrial discharges, agricultural runoffs. The limits are available for drinking water, less than 200 milligram per liter. The nitrogen and its compounds, there are different forms of nitrogen are there, particularly in wastewater terminology concerned. This nitrogen comes from the nitrogen cycle So end product of nitrogen cycle is nitrite or nitrate. Nitrate is the most stable form. Before that, nitrogen will undergo into different stages of decomposition in the natural cycle. The first one is called as organic nitrogen. It includes protein, urea, amino acids, and humic substances. Organic nitrogen can enter sewage as a bodily waste, discarded food material, or as component of cleaning agents. We are calling one more as ammoniacal nitrogen. It's called a free ammonia. It indicates a direct inclusion of organic matter in water from contamination sources. So ammoniacal nitrogen, we have detection limit, maximum 50 milligram per liter per inland surface waters and public sewers. Total Geldal nitrogen. So total concentration of organic nitrogen plus ammonia nitrogen. So we are having a Geldal method to detect this total Geldal nitrogen. The limits is 100 milligram per liter in the inland waters. And nitrogen compounds, if you see, next step is the albuminide nitrogen. It indicates quantity of nitrogen present in sewage before the decomposition of organic matter is started. Its presence gives an indication of organic pollution in water. So that is nothing but the Geldal nitrogen totally. And afterwards, we are having a nitrite and nitrate. Is a part of nitrogen cycle. Nitrate is unstable and nitrate is the more stable. So nitrates can arise due to biological disruption of organic matter. It indicates pollution and water or wastewater still undergoing anaerobic decomposition and stable position has not started yet. Nitrate is the final stage of oxidation process. It contributes to illness called blue babies in the water. Total nitrogen we are calling as a total Geldal nitrogen plus nitrite plus nitrate.